When we are doing problems using stoichiometry, we must ensure that we are working with a balanced chemical equation. So the first step that we must take before we start anything with these example problems is to balance this chemical reaction. So you first ask yourself, is the equation balanced? So looking here, I already recognize that there's 3 carbons on the left and only 1 carbon on the right. So I'm already seeing that it's unbalanced. So in order to balance, we're going to go through the process that we've learned. And then once it's balanced, then we're going to apply mole ratios in these examples, okay? So let's first work on balancing and then we'll move on to these examples. So we have propane gas, C3H8. So propane gas is used in your grill to cook food. So when we burn propane gas, it forms carbon dioxide and water. Water in its gas form, okay? Because this happens at very high temperatures. Okay? All right, so now what we should recognize is that there's 3 carbons here on the left and only 1 on the right. So the first step I want to take is put a 3 in front of the carbon dioxide to balance the 3 carbons. The next step, we have 8 hydrogens here on the left, 2 hydrogens here on the right. So we need to put a 4 in front of the hydrogen here to make 4 times 2, which would be 8. Now, the last step is the oxygen. There are 2 oxygens here on the left. Now there is 3 times 2 is 6 oxygens plus 4 oxygens here. Remember, this 4 gets distributed to give us a total of 10 oxygens on the right. We only have 2 here on the left. So I'm going to put a 5 in front of the oxygen. So now that it's balanced, what this is now communicating is that 1 mole of propane reacts with 5 moles of oxygen to form 3 moles of carbon dioxide and 4 moles of water. Okay. So chemical equations are like a recipe. We must recognize that we are talking about amounts here that are combining together to form product. Okay. So now that we have our balanced equation and we understand what our balanced equation is communicating to us, now let's look at the first example that's on that slide. It says, how many moles of propane can react with 20 moles of oxygen gas? Okay, so now this is asking for the relationship between the oxygen that's reacting with the propane. So referring back to our equation here, we see 1 mole of propane reacts with 5 moles of oxygen. That we can identify as a mole ratio, okay? So we can say 1 mole of C3H8 per 5 moles of oxygen, okay? That's the relationship in the chemical equation for the amounts that react with each other For every 1 mole of propane, there's 5 moles of oxygen that reacts. Okay. Now the question said, if we are reacting 20 moles of oxygen, how many moles of propane is reacting? So we're going to start with 20 moles of oxygen. Okay. We're going to use this as a conversion factor. We can actually use it as is. The way this is written right now allows us to cancel our moles of oxygen diagonally. So we're going to put 5 moles of oxygen on the bottom. Okay. And 1 mole of C3H8 on the top. So by using this as a conversion factor, we can now identify that 20 divided by 5 would tell us that 4 moles of propane would need to react with 20 moles of oxygen. Okay, so since we know this ratio, we can use that ratio to solve for the amount of propane. Okay, and we're using dimensional analysis through this. Okay, so I know that in ratios, you can sometimes set things equal to each other and solve, but we are not doing that in what we are completing here, because we are going to be learning other steps too, which will be required for us to use the mole ratios. So get in the habit of using the mole ratio as a conversion factor. We always start with our given information, then use the fraction, cancel the units diagonally, and then you're left with your desired units and you do the math. Okay. The next example that is on the PowerPoint slide, using the same chemical equation. Let's read it together. It says, how many moles of carbon dioxide form using 18 moles of propane? So this time, the given information is the amount of propane that's going to be reacting. And we want to know how much carbon dioxide is being formed from that amount of propane that is reacting. Okay, so let's go back to our whiteboard here and look at our chemical equation. Erase this for right now because that's a different problem. Now, the problem that we're considering is how much CO2 is formed from 18 moles of C3H8. Okay, so our question here, so this is how much moles of carbon dioxide. Okay. How many moles of CO2 is formed from 18 moles of propane? Okay, so it says here, 1 mole of propane reacts to form 3 moles of carbon dioxide. So 1 mole of C3H8 forms 3 moles of carbon dioxide. Okay, that's the mole ratio there. So it's from the coefficients. Remember, if there is no coefficient written, it is assumed to be 1. Okay, so this is like a 1 in front of the C3H8. Okay, so that's saying 1 mole of propane reacts to form 3 moles of carbon dioxide. So now let's say we have 18 moles of propane. So 18 moles of propane is what we're going to start with. C3H8. Okay, we're going to use the ratio as a conversion factor. Okay, if it is not used as a conversion factor, you will not receive credit for the problem. Okay, so we have to ensure that we're setting it up using this as a conversion factor. Now let's recognize here, in order to convert moles of propane to moles of carbon dioxide, we need to flip this ratio. We're going to flip this to put the moles of propane on the bottom and 3 moles of carbon dioxide on top, because it's asking for us to solve for moles of carbon dioxide. Okay, so when you're solving for moles of carbon dioxide, we need to have that on top as our desired unit. So now we're changing moles of CH3H8 or C3H8 to moles of carbon dioxide. So now you're recognizing why it is important to include the compound formula with the unit, because we're changing to different substances. Okay, so this is important because you have to understand what it is that we are changing between, because we're working with different substances and we're looking to determine what's reacting with what and how much is being formed. Okay, so this is not just about numbers, it's about understanding what is happening within a chemical reaction and what amounts are being used. Okay, so remember, think of a chemical equation like a recipe. Okay, we're combining different amounts together in order to form a certain amount of products. Okay. So in this case, if we had 18 moles of propane, how much carbon dioxide is formed? We multiply 18 by 3, and what that should give you is, let's do this in my head for a moment, 54. All right, I don't trust myself in my head. Yes, okay. 50, I need to do what I tell my students. I always tell my students, trust yourself. And then, you know, it is what it is. Okay, so 54 moles of carbon dioxide would be formed if you are reacting 18 moles of propane.